In this video, I'll explain a little bit further how linear regression model is updated, how linear regression model is trained through machine learning algorithm. So in the last example, I give a simple example of how model is trained with just one single data, but in reality we have this number of data. So let's say I have m number of data. So here this is the size of data, and in our case this m is number of compounds, so we have m compounds, and these feature descriptors have n dimension. So shape of this matrix is m by n, and we also have endpoints. So we have m endpoints for m different compounds. So in this case, I have a model like this, P-specificity value with, I put it as A, but actually it's a W, like the previous slide. So it's W1, W2, W3. These are the weights. And if the all weights are 0, then this model will give 0 all the time. So all the compounds prediction will be 0. But in the last slide, I just put this value, the difference between the label and the prediction value. But in actually when the errors are calculated, it calculates from all the compounds. So from compound 1 to compound m, these all values are calculated. So these errors are calculated, and then squared error are summed and then divided by m. So it's actually average of the error, squared error. And these are the error terms. And when this equation is differentiated, since this part is actually this equation, this whole equation can be differentiated by each weight. For example, this error can be differentiated by, well, like this. So this is a gradient for the weight A1, and other gradient for different gradient is also calculated in this way. So I said that differentiation of the error is used to update the weight, and in fact this differentiated value, which is also called gradient, is used for each weight to update it. So this gradient is added to the previous weight. So that's how these weights are changed. It may increase or decrease, but we say it's a gradient descent because if this is an error, let's say the first step, the errors were quite high, but it will be gradually decrease. So this is a normal learning curve if machine learning algorithm works well, because eventually these gradients differentiation of the error on the each weight will eventually make the model converge to a certain level where error is sufficiently small so that the model can be used to for the prediction of the compound. So in this case, so these machine learning algorithm actually finds set of weights where model performs statistically model's prediction error is statistically low based on the entire data set. So some may have a higher error, but it will have a lower error values for the most of data set. So that's what I mean by that when I say the model's error is statistically low, which means average of the error is very small, which means most of error values for the compounds are low, but some compounds may have higher error values. So these machine learning algorithms find a set of weights that the model makes generally good prediction over the entire dataset, not the each of dataset, because some people who use the model expects that every prediction should be accurate, but actually that's not possible because it's finding set of weights where model's error is low on average. So people who want to use the model should put this in mind, that the model is not giving a good prediction for every individual of dataset. It's just a average. It's just working well generally, not for every dataset. So these gradient is used to update the weight, and actually this process is repeated until the model's performance is satisfactory. So I just repeat the machine learning algorithm, but this time I explain a little bit further how errors were calculated.